This is a simple introduction to stress, normal stress. And it's interesting that any semester I have a question from a student, at least when we have situations like this, we have a force pulling on in a vector on the right side and another one on the left side, and the questions come up: should I use both of them when I use the solve the problem? So here it is how we do it. As we are searching for stress in elements of this case, we have a buckle, and you can see that this is, as they were saying, this is the cross section there with the dimensions, and we have two of them. So definitely, when we are taking the cross section, then we, as we mentioned, we use either the left side or the right side. So in this case, we use the right side, and we are building a free body diagram. And of course, we have that P that was given as 900 pounds. And in the cross sections that you're putting there, of course, here it's important for us the normal stress. So that's why we were interested only in using the these loads, not the moment. Anyway, we can see that this horizontal normal loads on the cross section. We having two cross sections. We have two of them. There are two arms on the turnbuckle, but I think the moment when we select the right side or the left side, that answers to the question that students are putting it, should I use two of them or one? And the answer is use one, because we are taking the cross section and we select either on the one on the left and one on the right. The reason it's put there, generally speaking, for these situations, for most of the problems, the two loads are put there just to indicate that there are extension in both directions. The most of the applications, one end is fixed and the load is applied on the other end. But it doesn't matter. If you take the left side, you still have the same load there, that is pulling in here, because you will have a tension in cable or a tension there, so which it will oppose the load that pulls on the right side. So the answer is we use only one. And then the problem becomes very simple by solving Newton's second law in the x direction, and we find this internal loading, normal internal loading NAA, as being 450. And then by definition, we use that one to calculate the stress in the material in the cross section. And we can see that even though we put two of them, now we are looking and we have two turnbuckles. The focus is only in we use only that cross section, not two of them, because we divided each normal in each cross section. So we have that area of this cross section as calculated with 1 inch at length and a quarter of inch in width. So that's exactly what we were doing here, and the stress will be basically 1800 pounds per square inch, or we can say it this way, psi, another way to denote it, the pounds per square inch. Or most of the time we are using it for metals, what is called the KSI, which is K comes from the kilo. In metric we use that signifying 1000 of units. In this case the units are pounds per square inch, so that would be 1.8, the result, kilopounds per square inch. And the same way, the problem is asking not only there to find the normal stress, but also in the sides of the turnbuckle, but also in the shank of the bolt. And it's giving us the diameter of 0.5 inches. So again, we are building, we take the shank right here. We are building another free body diagram. And the normal load there would be basically, by observation, you can see is 900 pounds. Of course, the area being a circle in this case, it's a pi r squared, and I usually put it r when it's very simple, so we can get half a diameter, which it's going to be a quarter of an inch, the radius. So again, we do the same ratio, take it, and we find the stress in shank of the bolt as being 4.58 ksi. I hope this introduces you to very simple to the stress, and in answering this question, they could be confusing when we are looking in the beginning of the problem where we have a load pointing to the left and another one pointing to the right. Have a beautiful day.